Hello everyone. Welcome to Reboot and Rise with MLR. In our last video, we have covered some basic fundamentals of computers, from hardware, software, networking, and to the idea of computer program and the need for programming language and translators. Now that we are ready to begin our journey into Java, let's take a step back and understand why Java was created, what problems it solved, and how it became the powerhouse language it is today. Let's understand the background and evolution of Java. Back in the early 1990s, the companies building the consumer electronics like TVs, set-top boxes, home appliances were facing some challenges like especially to control and manage those devices. So that's where they were looking for some universal software platform. The idea was once the software was built using a language that could run across all the devices and it had to be robust, secure and platform independent. And most importantly, no code changes when moving between different hardware. Think about it. If you write a software for setup boxes and want to work on smart fridges, rewriting from scratch is not efficient. That's the problem they wanted to solve. The key requirements was robust, secure, platform independent. So let's break that down. When I say robust, the software should handle the errors gracefully and avoid any crashes. Security, preventing the unauthorized access or misuses, and this is critical in connected environments. Platform independent, write code once, run anywhere. This led to the principle called as write once, run anywhere principle. This concept was the spark that led to the Java development. Today, we still associated Java with write once and run anywhere. In devices with limited computing power like embedded systems, write once and run anywhere was the game changer. You could build a software once and run it across microwaves, TVs, and set-top boxes. And with that in mind, in June 1991, Sun Microsystem, a small group called Green Team, they started a journey to develop this Java language. The key people involved were James Gosling, Mike Sheridan, Patrick Norton. And their main aim was to build a lightweight and platform independence language. So initially, this language was named as GreenTalk, and the file extension they were using was .gt. And then the Green Talk was renamed to Oak, and after an oak tree outside of Gosling office. Finally, in 1995, Oak was renamed to Java, and it was inspired by a coffee from Java Island. Okay, and then once it was renamed to Java, and it is no longer for TVs. It's moved beyond TVs and it moved to web, enterprise, and mobile apps. It also gained massive adoption from developers because of its simplicity and portability. And today, Java is one of the most used language and it is supported by almost like a 10 plus million developers globally. And in some stats, I read like 17 million plus developers. And Java is running in billions of devices across global. Though initially Java was designed for embedded system, the consumer electronic market was not ready for that technology at that time. Instead, Java found a massive success in web development, enterprise applications, and mobile devices like Android. Okay, so that's the background of Java and evolution of Java. Let's move on to next. Now, let's understand how a typical Java project progresses from an idea to fully deployed product. The first phase in development lifecycle is planning, where we define goals, scope, budget, timelines, and a team. Then we move to analysis, and of course, the planning phase is the foundation phase. A well-planned project avoids the last-minute disorders. Okay, so we should be careful about in the planning phase. In the analysis, where we gather detailed requirements, functional like what it does, and non-functional requirements like how it does, how it behaves. And we also consider some infrastructure like network, operating system, hardware. This is like a discovery phase. We involve stakeholders early and clarify the things. And we move to design, where we do high level architecture, technology stack, and low level designs like classes, object, methods, and workflows. In case if it involve in user interface development, so we design UI and UX, where layouts and user interactions. And then we move to implementation. Like this is where we actually, as a Java developer, we start coding. This is the coding phase. So we use Java with best practices like clean code, naming conventions, comments, and a few other best practices. Along with writing code, we also write unit tests for testing our code. And this is to make sure like our code is reliable. And we also focus on OOPS principles like encapsulations, inheritance, polymorphism. Okay. And once we successfully completed our coding part in the implementation phase, then we will move to deployment. Okay. So in the deployment, what we do is like whatever the code we have written in our Java programs, we compile and then we will compress them into a deployable file like a jar or var or some other format, and we'll deploy them into a pre-production environment first, like a staging environment, preview environment, or user acceptance environment. Make sure like your functionality or features tested thoroughly, and then we will push our code into production. So this is another serious and critical phase. Like we should never skip pre-production testing to make sure like your code is bug-free code in the production environment. So once deployment is completed, then we can say like we are in maintenance. Like that's where the code or the software that is deployed in production is ready to use by the end users. And in the maintenance phase, like we will keep monitoring the performance of our application that is deployed to production and look for any bugs or any update, feature updates or patch releases. And based on the feedback or if any bugs comes, so we will revisit in the planning and again the cycle begins. Please note the software development is iterative, so it's not a linear. So agility and feedback loops are the key. Okay. Then coming to the next one is let's look at the Java flavors. I mean, like if you want to work on Java language, so we have a three flavors of Java language or three main editions. So each edition or each flavor serves different purposes. So the first one is we have a JSE, so also called as J2SE, Java Standard Edition or Java 2 Standard Edition. So this is best for developing the desktop applications, apps, tools, utilities, or standalone applications. And this is a core Java based programs. Okay. And this includes some important libraries like collections, input output, networking, threading, and database access. And JSE is the base. So you must learn this before you move to learn any other Java editions. Okay. The next flavor is JEE, also called as J2EE. Earlier it used to call J2EE Java Enterprise Edition or Java 2 Edition Enterprise Edition. So this is used to develop large scale web applications, client server applications, and enterprise applications. So JE includes some APIs such as servlets, JSP, EJB, Java Persistent API, JPA, web services. And JE now it is called as a Jakarta EE because I think somewhere around 2019 This JEE part was acquired from Oracle to Jakarta. From there onward, this JEE called as Jakarta EE. And the third version or third flavor is JME. And of course, earlier it is called as J2ME, Java to Micro Edition. And this is used for developing applications for embedded systems, mobile devices, and consumer electronics such as smart cards. This is the lightweight of all the other flavors, and it requires very less resources to run. I mean, if you develop any software using JME, that require very lightweight and less resources to run that software. Okay, and of course, JME is very niche, but it's still useful in embedded and I mean, like compared to Android and other devices. Coming to the Java standard edition components, as in like, okay, now we learn about the Java flavors. And if you want to write our Java application and run our Java application, so we need these Java standard edition components. So we have mainly two components or two products. One is Java runtime environment, where it runs the Java program. So JRE, it includes JVM, Java Virtual Machine, plus some core libraries. So this doesn't have tools like compilers and debuggers. And that's where we need compilers. So compilers are available in the Java development kit. So basically, like this Java development kit is a superset of JRE. That means it contains JRE plus the other development tools like compilers, Java debuggers, and utilities, and basically that are required for our Java development. Okay. And other important component we need to understand is Java virtual machine. So basically it converts our bytecode in the sense like once we write our code, our source code using Java language, we need to compile. So once we compile, that's where we get something called as bytecode, and that bytecode will be is the input to virtual machine. So what Java virtual machine reads that bytecode, convert it into machine level language. That's a zeros and ones. Okay, and and this is, I mean, this is the foundation for what we call as write once, run anywhere, and JVM makes platform independent. So what does it mean is like Java is the heart of Java platform independence. So one JVM per operating system. So if you download a JVM for OS, example, if you download JVM for Windows, the same JVM will not work for Linux. So you need to download the JVM for Linux version. Okay. And if you see the relationship, so JRE, as we discussed earlier, it contains JVM and libraries, and JDK, it's a superset of JRE, so that means it contains JRE plus compilers and debugging development tools. Okay, so that's it. Like to wrap up, so we have seen in this video like why Java was created and what was the problem it was solved, and how did it evolve from embedded system to enterprise apps, and Java development lifecycle, and different editions or flavors of Java, and what are the components of JSE that we need to write and run our application. So in our next session, we will dive into like how do we download this JDK and JRE, and how do we install and how do we set up those things in order to write our Java program and compile it and run it. Okay. So I'll see you in the next video. Until then, keep learning, keep coding. Thank you.